Hi everyone. So we're in section 3.4, graphs of polynomial functions. And so I just want to spend a little bit of time talking about a couple more things that we want to look for to graph a polynomial function. And so the first thing that we want to look at is the behavior at the x-intercepts. So let's suppose that c is a 0 of the polynomial f of x with multiplicity k. So what does that mean? That means x minus c to the k is a factor of f of x. Alright, if k is even, then the graph of f of x touches the x-axis at that x-intercept. Okay, so even means that it touches. The multiplicity is even, it's going to touch at x equals c. If the multiplicity is odd, then the graph of f of x will cross the x-axis at x equals c. So again, when the multiplicity is odd, the graph crosses. So if you're thinking about what your graph looks like, what this says is, if it's even, it's going to touch. So when you come to your 0, you just come and touch the x-axis. If it's odd, so say this is my 0, if it's odd, it crosses through the x-axis. Alright? So let's look at an example. Suppose f of x equals x minus 2 cubed times x plus 1 squared. What are the zeros? Well, I set the whole equation equal to 0. And this is already factored for us, so we get x minus 2 equals 0 or x plus 1 equals 0. So here are our zeros. X equals 2 is a 0 with multiplicity 3. 3 is odd, so the graph crosses at x equals 2. X minus 1 is a 0 with multiplicity 2. 2 is even, so the graph is going to touch at x equals negative 1. Okay, so remember this, we'll come back to this example. Here's another example. Let's suppose g of x equals x cubed plus 2x minus 3x. So if I want to find the zeros, again, I set the whole equation equal to 0. I can factor in x out, and I'm left with x squared plus 2x minus 3, and that factors as x plus 3x minus 1. So my zeros here are x equals 0, negative 3, or 1. All of these are going to have multiplicity 1, which is odd, so what happens at the graph? At each of these zeros, the graph is going to cross the x-axis. Alright. What about the end behavior? So let's suppose that your polynomial looks like an x to the n plus an minus 1 x to the n minus 1 plus a0. This term an x to the n is called the leading term, and the coefficient an is called the leading coefficient. So we want to pay attention to what n is and what that leading coefficient is. So there are 4 possibilities. If n is even and an is 0, greater than 0, then if we go to the left, so if we take x to be closer and closer to negative infinity, the graph is going to go up towards positive infinity. And if we get closer and closer to positive infinity, the graph is going to go up towards positive infinity. So we draw this picture here to say that the graph goes up on either side. So the end behavior of my graph is going to be pointing up towards positive infinity in both directions. My second possibility is n is even and the leading coefficient is negative. When that happens, the graph is going to go down towards negative infinity in both directions. We could also have n odd and an greater than 0, so an is positive. In this case, as x is closer and closer to negative infinity, the graph is going to go down. As x gets closer and closer to positive infinity, the graph is going to go up. Finally, n could be odd and an could be negative. And in this case, as x is closer and closer to negative infinity, the graph will be going up towards positive infinity, and it will be going down towards negative infinity off to the right. So these pictures all tell us what the graph is going to look like at the ends. All right, and we're going to use that to help us to graph a function. All right, so let's try describing the end behavior of the polynomial f of x equal to x minus 2 cubed times x plus 1 squared. Now, if you were to factor this polynomial out, what would happen? I would get an x cubed term from this first product and an x squared term from the second product. X cubed times x squared gives me an x to the fifth. And I could multiply out the rest, but all I really care about is the leading term. So here, my n is 5, and my an is 1. Now 5 is odd, and an is positive. So what does that mean? My end behavior is going to go down to the left and up to the right. Let's try graphing f of x. So the first thing you want to do when you need to graph a function is find the zeros. We did that earlier. So let's make a table. We found that 2 was a 0 with multiplicity 3, and negative 1 was a 0 with multiplicity 2. So the graph crosses at 2, and it's going to touch at negative 1. Secondly, you want to find the end behavior. We just found that the end behavior looks like this. So let me copy this on the next slide. Go a little faster. Okay, the next thing that we want to do is, whoops, here's the function. So let's try plotting what we know. So here's a grid. And I've marked my zeros at negative 1 and at 2. All right, the third step is to plot some points in between my zeros. So you just want to pick some values for x. You should find the y-intercept. That's the first easy thing to find. So if I plug in 0, I'm going to get negative 8. So let's change our scale on the y-axis to go by 2's. Okay, so at 0 I get negative 8. If I plug in negative 2, I'm going to get negative 64. That's way down off my screen, so I can't plot that, but we know it's going way down at negative 2. If I plug in 1, I'm going to get negative 1 cubed times 2 squared, which is negative 4, so let's plot that. And if I plug in 3, I'm going to get 1 cubed times 4 squared, which is 16. Again, that's off my grid. Alright, so the next thing you want to do is just connect these points. So I know, let me undo this, and let's try graphing this again. So I know that the graph is going to cross through at 2. So let me just draw a line there to remind me it crosses, and it touches at negative 1. Since I plotted the point negative 2, I know at negative 2 the graph is down at negative 64. So I know it's down below the x-axis. So it's going to come from this direction and touch, and then it's got to come through and touch the y-intercept, and it's got to come back up to this 0. Now my end behavior up here tells me that to the left the graph is going down, and to the right the graph is going to shoot up. So this is a good sketch of what this graph is going to look like. You should plug this into your calculator and see that you get something that looks like this. Alright, what I'd like you to do is try the rest of the examples in the notes. Try to graph them and try to see if you can determine the end behavior and the behavior at the zeros. Please email me with questions and be prepared for questions in class on Tuesday.